All right, good morning, everybody. This is David. We're going to go ahead and get started. I want to thank you for tuning in to our June webinar in our Science in the Wildlife Commission series, Understanding Our Wildlife. So with that, our presentation today is by Christopher Smith. Chris is our District 1 fisheries biologist, and his presentation is using annual monitoring to evaluate short-term environmental impacts to fish populations. I appreciate you being here, Chris, and with that, I'll turn it over to you and let you take the presentation.
Thank you, David. As David mentioned, my name is Christopher Smith, fisheries biologist here in District 1. Today, I'll talk briefly on using annual monitoring to evaluate short-term environmental impacts to our fish populations. Specifically, I'll be giving an example of how we use our annual largemouth bass surveys here on the Roanoke River and the data we collect from those to evaluate population recovery following hurricane-induced fish kills. So our coastal rivers are being affected more often as hurricane frequency and intensity increases. In context of the coastal rivers, rainfall and storm surge are the two major issues associated with the hurricanes. This heavy inundation of our floodplain flushes organics into our waterways. These organics oftentimes include animal and human waste, which is the case that we've seen on the Cape Fear during Hurricanes Bertha, Fran, and Floyd. The breakdown and decomposition of these organics oftentimes result in hypoxia, which is when dissolved oxygen levels are less than 2 milligrams per liter, and it can result in anoxia, which is when there's no detectable dissolved oxygen in our water. So these hypoxic or anoxic conditions that last for more than a day will cause fish kills. The longer these events and conditions last, the more intense the fish kills will be. These conditions and fish kills aren't new to us as scientists. We've seen these from the Chesapeake Bay down the East Coast to Florida, and then west along the Gulf to Louisiana. These fish kills have the potential to alter our fish communities, as well as the potential to alter our population characteristics, such as relative abundance and length distributions of important sport fish, such as largemouth bass. Our agency and our anglers are heavily invested in the conservation and rebuilding of our resources and our fisheries. So, following Hurricane Isabel in 2003, our district staff developed a hurricane response plan, and this plan has been refined in subsequent years to what we have today. Kevin Dockendorf gave a great in-depth view of hurricanes and the response plan on one of his Nature Break presentations, and you can find that on our YouTube channel. But for today's presentation, I'll just briefly go over the response plan. Our first step is to assure our personnel and our equipment are safe. The second step is to document the extent and duration of the hypoxic event and the fish kills. Next, we will survey the largemouth bass in and around the affected area that fall following the hurricane. The fourth step is to survey the area again, the same exact sites, the following spring. And then that next fall, we'll survey once again those same sites, trying to look for juvenile fish recruitment. At each step during this process, we evaluate the data and consider all management options available to us at the time. So the data that I'm going to present to you today is from the Roanoke River and the population recovery following Hurricane Irene in 2011. Irene made landfall near Cape Lookout on August 27, 2011, and its path took it directly over the Pamlico and Albemarle Sounds as a hurricane. Irene flooded the Albemarle Sound area with anywhere from 7 to 10 inches of rainfall. And as I mentioned in previous slides, this heavy rainfall flushes nutrients from the floodplain, resulting in potentially hypoxic or anoxic water conditions. And that's exactly what we saw following Hurricane Irene. We saw a drastic decline in our dissolved oxygen levels, which started a day after landfall. If you take a look at this figure here to the right, this is two graphs, both the surface and bottom dissolved oxygen readings following Hurricane Irene. I pulled these from a USGS gauge just located just downstream of Plymouth, North Carolina. You can see on the surface here, following landfall, we see this drastic decline into hypoxic conditions here, which is followed by several weeks of anoxic conditions, so no oxygen levels. And almost a month later, we see this rebound to about 4 parts or 4 milligrams per liter, which is about normal conditions. Through various water quality gauges and water quality surveys, it was estimated that hypoxic conditions impacted approximately 46 river miles in the Roanoke River. Just for as a comparison, the Kashai River, which is adjacent to the Roanoke, it was estimated that hypoxic conditions there impacted roughly 24 river miles. And in the upper Chowan River, still in the Albemarle Sound area, hypoxic conditions impacted 31 river miles. So fish kill surveys conducted by our biologists estimated approximately 50,000 dead or dying fish in the Jamesville and Plymouth areas. Most of these fish were largemouth bass. However, given the extent and duration of the hypoxic event, it's likely that this is a very conservative estimate. So our annual largemouth bass surveys are conducted using a boat mounted electrofishing unit, which you can see here to the right. We've completed anywhere from 10 to 20 shoreline transects during the fall of 2011 through 2014, and then once again in the spring of 2012. At each site, largemouth bass were collected and held in a live well until the completion of the site, where they were then weighed, measured, and released back into the river. From this data, we can estimate relative abundance, and we use that with an index of catch per unit effort, or CPUE. And you'll be hearing me talk about CPUE here in the next few slides. And the way we calculate catch per unit effort is just the number of largemouth bass divided by our electrofishing effort, with the units being fish per hour. So each year we sample sites in both the Roanoke and Kashai rivers. For this presentation, I'm going to just focus on sites from what we call our lower Roanoke strata, and you can see those sites here in red. They stretch from the confluence of the Albemarle Sound and the Roanoke River upstream to the Highway 17 bridge just inside Williamston. So diving into some of the data that we collected, this is a figure of relative abundance. On the x-axis, you have our sample year. The y-axis, you have our catch per unit effort in fish per hour. Notice you have two different bars here. We have catch per unit effort, or overall catch per unit effort, in our gray bars, and the catch per unit effort of fish 8 inches or greater in the black bars. Generally speaking, in coastal rivers, 25 fish per hour of fish greater than 8 inches is usually considered a healthy population. So looking at 2010, you can see that we have high catch per unit efforts both overall and of our larger fish greater than 8 inches. Moving on to 2011, this is immediately after Hurricane Irene had come through. Water quality had returned. We saw drastic declines in both our overall and our catch per unit effort of fish greater than 8 inches. Moving on to 2012, we see a huge spike in our overall catch per unit effort. And in some of the upcoming slides, I'll kind of talk about that huge spike and what may have caused that. But more importantly, we still see low catch per unit effort of our fish greater than 8 inches in length. Moving on to 2013 and 2014, we do see a steady increase in our overall catch per unit effort in relation to the 2011 data. But more importantly, we see our catch per unit effort of fish greater than 8 inches reach that kind of benchmark, or that 25 fish per hour mark in 2013, and it exceeds that mark in 2014. So this figure shows our length distribution, or our size structure pre-Hurricane Irene in the fall of 2010. On the x-axis, we have our total length. They're in 1 inch bins. And in the y-axis, we once again have our catch per unit effort in fish per hour. This figure is what we normally would consider a healthy largemouth bass population. We have a expanded size structure ranging from 3 to 20 inches. And we are seeing relatively high catch per unit efforts for each size class. And that was ranging anywhere from 4 to 6 fish per hour. If you notice our lower catch per unit effort for larger fish, that's very typical of what we see on the lower Roanoke River. Moving into post-Hurricane Irene in the fall of 2011, once again, this is immediately after the hurricane had passed and water conditions had cleared up. We see this is what we would consider a unhealthy population. We see this truncated size structure. We see missing size classes. We also see very low catch per unit effort of the fish that we do have. So per our hurricane response plan, we sampled again in the spring of 2012. We continued to see this truncated size distribution, these missing size classes here, and we continue to see very low relative abundance, or our low catch per unit effort. So as fisheries biologists and managers, what do we do now? So a report by Thomas and Dockendorf in 2009 recommended that largemouth bass stockings should occur if spring abundance is severely reduced. So following our low abundance in the spring of 2012 and from interest from local angling clubs and groups, we stocked approximately 120,000 largemouth bass fingerlings in May of 2012 around the Plymouth and Jamesville area. These fingerlings ranged in sizes anywhere from 1 to 2 inches in length. Continuing on with some data from the fall of 2012, we continue to see low relative abundance, or low catch per unit effort of fish greater than 8 inches in length. But we have seen, or we see a high abundance or high catch per unit effort of fish 2 to 8 inches in length. So this is a good sign for fisheries biologists. That means spawning and recruitment is occurring, or has, in this case, has occurred. But were these elevated catch per unit effort numbers natural, or were they due to stocking? So if we break down this this data into sites that were stocked, which are in gray, and sites that were not stocked, which are your dashed bars, you can see for the most part, especially with these smaller fish, stock sites had a higher catch per unit effort than those sites that were not stocked. However, you can see in comparison that these sites that were not stocked also had high catch per unit effort. So that is some indication to us that natural reproduction and recruitment has occurred. Moving on to the fall of 2013, we're starting to see natural spawning and recruitment occurring, which is evident by these smaller fish here. And we're seeing a relatively good catch per unit effort of those smaller fish. Our length distribution is starting to expand. We're starting to see fish between the 9 through 15 inch range. We're also starting to see fish over 20 inches. And we're starting to see an increase in abundance in these length classes that were almost non-existent following the fish kills in 2011. Moving on to the fall of 2014, once again, we continue to see these signs of natural recruitment and spawning occurring with these smaller 2 to 6 inch fish. Our abundance of 8 inch fish or greater has increased, and we're even seeing fish upwards of 22 inches in length, which is a good sign. So just looking through this brief, just a brief summary of what the data showed. We had a catch per unit effort of fish greater than 8 inches in 2013, which also exceeded the 25 fish per hour mark in 2014. 3 years following the fish kills, we saw expanded length distributions ranging from 3 to 22 inches in length, which were similar to pre-Hurricane Irene data in 2010. We saw both natural spawning and recruitment occurring 2 to 3 years later. So did stocking help? That's kind of the main question. Well, it surely didn't hurt our recovery at all. But without genetic analysis on these fish, it's difficult to determine our hatchery contribution of the smaller fish that we saw during the fall of 2012. However, currently we have the ability to evaluate hatchery contribution using genetic analysis following any and all of our stocking events. So more recently, 2018 and 2019, Hurricane Florence and Dorian caused hypoxic conditions once again in the Roanoke River. Hurricane Florence made landfall in September of 2018, while Hurricane Dorian made landfall almost a year later in September of 2019. Both storms produced rainfall totals in the Albemarle Sound area exceeding 7 inches. Hypoxic conditions occurred once again in the main stem and the tributaries of the Roanoke River. And in both years, these hypoxic conditions lasted anywhere from 5 to 7 days. Once again, as in previous years, fish kills did occur during these hypoxic events, but unlike during Isabel and Irene, these fish kills were not as intense. So if we look at some data collected in 2018 and 2019 following Florence and Dorian, 2018 is your gray bars. Once again, we have our length distribution on our x-axis in total length, and our catch per unit effort in fish per hour on our y-axis. You can see that in 2018, we had a low abundance of fish, but we did see a wide distribution of size classes. Looking at 2019, which is our black bars, we did see some natural recruitment and spawning that spring. We also saw an increase in catch per unit effort of our fish 8 inches or greater when compared to 2018, which was very promising to us. So our sampling in the fall of 2020 and our data was limited due to COVID and COVID restrictions. So given that fact and the promising data that we saw in the fall of 2019, we focused our sampling on the Kashai River, which seemed to, the populations there seemed to take longer to recover, and water conditions seem to take longer to recover as well when compared to the main stem of the Roanoke River. So hurricanes, fish kills, and population recovery is nothing new to our coastal region fisheries biologist. This slide is just to give an idea of the work that we have done with these topics and the hurricane response plan. It started with Isabel and the Roanoke River. During Irene, we've done work on the Tar, the new White Oak rivers, the Albemarle Sound tributary rivers, Neuse, Trent, Chowan, Meherrin rivers, the Northeast Cape Fear River, and like I presented today, the Roanoke River, and more recently, Dorian and Florence and Dorian on the Roanoke River, which I gave some preliminary data on today. Our great fisheries biologists in District 4 are working with our wonderful Watha hatchery staff to restore sport fish populations on the Northeast Cape Fear, and that's currently ongoing and will for several more years. So what does this mean long term? Well, we can't control our environmental conditions, and we can't predict which years we're going to have hurricanes impact North Carolina. But we do have protocols and tools for recovery that have been shown to be successful. We have our hurricane response plan. We have great staff at Watha Fish Hatchery that allows us to easily stock fish, and it makes our job a lot easier working with them. We have genetic analysis that allows us to identify hatchery-raised fish with near 100% certainty. This allows us to identify or determine if stocking is actually the method that is causing our populations to recover, or if it's actual natural recruitment and spawning. We have water quality gauges and loggers that are relatively inexpensive and easy to maintain. This allows us to examine water quality more closely and perhaps find areas of refuge during these hypoxic events. And what I think is often overlooked is our outreach. Our anglers and our conservation groups are a huge resource and asset to us as fisheries biologists and managers. They're very passionate about our fisheries and conservation, so keeping them informed of our research and survey results, and as well as our upcoming field work is very important. So to leave you guys with a kind of a bumper sticker slogan or statement, our largemouth populations can recover if given the opportunity. If they are not impacted year after year by hypoxic events and fish kills, it takes about 3 to 4 years before we see recovery. So with that, I'll leave you guys with some photos of large bass that we have collected since the fish kills in 2011. Thank you, and with that, I'll take any questions.
Thanks, Chris, for that great presentation. And again, I'd ask anybody with questions to drop those in the chat. I'll start you off with one. We've heard not only presentations in this series, but also other venues within the agency about Alabama bass.
Mm-hmm.
Relative to everything you've presented, what influence, if any, do you think this whole issue of Alabama bass might have on the types of recovery patterns that you've seen?
Well, thankfully, so far we haven't seen any Alabama bass in any of the genetic studies in the Northeast rivers. So, I think that during the periods of low abundance, if there are Alabama bass, they're going to hybridize with our largemouth bass populations. So that's going to be something that we have to look forward to if we do eventually see the Alabama bass in our river systems.
All right, great. Here, I'll ask you another one. You had a slide early in your presentation where you had the size structure of the population, and it was, at least to my eyes, yeah, I think that was it. At least to my eyes, that looks like a trimodal distribution. Is that typical in coastal bass populations?
Yeah, I would say so. Like I said, this is what we consider what I would consider a healthy population. We have, you can see here to the right, your smaller or left, your smaller fish, which are your recruits, your 8 to 12-inch fish, which were probably the previous spawn, and then you have your 12 to 20-inch fish, which are really our larger fish that are going to produce our offspring in the upcoming years. So, yeah, I would say that's pretty natural of a non-hurricane influenced or non-fish kill influenced population.
All right, great. All right, couple of questions from the chat. In your results post Hurricane Irene, it looked like smaller largemouth bass were more affected than larger fish, which is atypical for hypoxic events. What are your thoughts on this?
That's a good question. I so kind of one theory that I have is that these larger bass can migrate out of the affected areas a lot easier than these smaller fish. If I can, I'll go back to this figure. A lot of our sites are relatively close to the Albemarle Sound. So kind of one hypothesis is that the fish closer to this Albemarle Sound migrate out to unaffected waters, or the fish in the sites near Williamston migrate upriver to escape the hypoxic waters or find a little bit better water conditions. So it's going to be a lot harder for these smaller fish, these 2 to 4-inch fish, to make those movements than it will be for our larger fish. So that's kind of one hypothesis that I have. And that's kind of one reason why we're trying to look more closely to possibly try to find areas of refuge during these hypoxic events.
Okay, next question is, has there been a correlation done between storms and post-storm fishing pressure?
Not to my knowledge. So going back to my outreach statement, usually, we're, at least here in our district, we're in touch with representative from the bass clubs. There's, I don't know, maybe 10, 15 bass clubs that use our rivers here in the Albemarle Sound area. And, usually they come to us. We don't even have to like invite them to a talk or anything like that. They usually come to us. Hey, what are y'all seeing? We've heard about these fish kills. Where do we need to go to not put pressure on these fish? So I haven't seen a study correlating that, and I haven't done a study correlating those two. But just anecdotally, I think knowing the bass fishermen know that some areas are more heavily impacted than others. They tend to kind of shy away from those areas when possible.
Okay, so this is a question, but there's like 4 question marks in it. So I'm going to break this up a little bit for you. I'll give you the intro part of the question and give you a couple of series. Seems like the jury is still out, but it appears natural reproduction / recruitment can restore a healthy native population following low or no oxygen events, seeing as this happened with native fish throughout history. So, first question. So, what is the rationale for stocking in the first place?
So, stocking. Let's see. Stocking, is kind of one. It's a lot of times driven by public perception and public interest. We've we've had not just with largemouth bass, but other species, anglers following events come to us asking us to stock largemouth bass, bluegill, whatever is impacted by these events. So, so stocking just kind of gives a little more added buffer to those natural populations to allow them to just kind of weather the effects of the upcoming year and bolster the fish that will survive the following falls or following years. So,
okay. So the second part of the question is, how does the interaction of stocking and natural reproduction affect the future conclusion of, quote, what contributes to restoration, unquote?
That's a good question. And now with our genetic analysis and our genetic tools, we can look at our hatchery contribution to our fisheries. We've done this at Lake Mattamuskeet when we stocked largemouth bass fingerlings for several years. I'd written a report that showed that hatchery contribution there was very low, and that the population was sustained by natural recruitment. I don't know of any fin clips taken during this time frame, or this research. But in future research, especially in the Cape Fear, I believe Kyle Rachels and April Boggs are planning to take fin clips from the bass that they are stocking there, and hopefully come up with a good conclusion on if stocking is contributing, or if the natural reproduction is the main method of recovery.
Okay. And then the last part of this question is really the last part is a 2-parter. What are anglers' responses to these events? Do they shift effort or do they keep it up?
I think the anglers' responses to these events are similar to ours. I mean, if you look at this photo here, this is, I believe, a picture taken from following Hurricane Irene. I mean, you got some nice bass there. You got some large bass, and they hate to see that, and we hate to see that too. So I think they're kind of disheartened with when these fish kills occur, especially if the population and has been great like it has been the last few years. But we can kind of cull or lessen their anxiety, with the day that we've seen following Isabel, Irene, and any of the the other systems where we have, 3 to 4 years recovery. So, being able to communicate that 3 to 4 year recovery time frame with them, helps them kind of relax and calm down a little bit. They, like I said before, they do. Some anglers tend to shy away from areas that were heavily impacted, which can put pressure on other populations. But for the most part, they're kind of receptive to this and kind of understanding to the current status of the populations. So.
All right, great. That's it for the questions in the chat. I'll just take a second to say if anybody has another one, drop it in there real quick, or just unmute yourself and you can ask it. Other than that, I'm going to again thank everybody for logging in. We do this webinar every second Tuesday of the month at 11 o'clock. And then, of course, Christopher, thank you very much for doing this. This was a great presentation. Very, very interesting information about how y'all take all of these data and all of this science and apply it to fisheries management in those rivers. And so with that, again, everybody have a good rest of your day, and we'll see you next time.
Thank you, David. Thank you, everyone, for joining.